This is Mr. Liao, and we're on AP Macro Section 3.2, the Multiplier Effect. Today we're going to look at several things. We're going to look at the difference between consumption and saving. We're going to look at the multiplier process, calculate spending and tax multipliers, and understand how we use the multiplier to determine changes in GDP. So if you recall, GDP is equal to aggregate demand, which is equal to consumption plus investment plus government spending plus net exports. Now, which is the largest component of aggregate demand? Well, it's consumption. So now the question is, what determines a person's level of consumption? Well, consumption depends largely on one's income. The more money you make, the more you have to consume. More specifically, it has to deal with disposable income, which is income consumers have at their disposal to spend. Usually it's defined as income minus taxes, so the money you have left over after taxes. So let's suppose you just earned $100. Congratulations. What are you going to do with it? Well, it turns out you can only do one of two things with it. You can either spend it, which is consumption, or you can save it, which is savings. So you either spend or save, consume or save. The average propensity to consume, the APC, is the proportion of their income that a person spends. It is consumption divided by disposable income. So APC is C divided by DI. So if you don't spend all your income, your APC is going to be less than 1. And if you aren't spending all your income, then you're saving it. Which leads us to the APS, the average propensity to save. It's the proportion of income that a person saves. It's savings divided by disposable income. I apologize for the slowness of my animations. Now, what about investing? Because people think, I don't want to just save the money, put it in a bank. I want to invest. I want to invest in stocks. I want to invest in mutual funds. I want to invest. I want to make more money. Well, in economics, investment is specifically a business term. It is buying equipment and buildings for production. It's buying capital stock. Now, when households invest in stocks, households are considered to be saving. Why? Because if you're saving and buying stocks and bonds or mutual funds, you're not consuming. So the opposite of consuming is saving. So you're foregoing consumption by investing in stocks. Now, if you will notice, a consumer can only spend or save. So let's suppose you have $1. Your consumption plus your saving has to equal $1. Therefore, the average propensity to consume plus the average propensity to save also has to equal 1, which means the proportion of income saved plus the proportion of income spent has to equal your total income. Now, when we were studying microeconomics, we were often making decisions on marginal analysis. So remember, marginal means change or additional. Consumers looked at their marginal utility. Firms ended up comparing their marginal costs with their marginal revenue. And we're going to do the same thing when it comes to consumption and savings. So first we'll look at the marginal propensity to consume. That's how much people consume rather than save when there's a change in income. So if you make another $10,000 and you spend 8,000 of it, that means your MPC is actually 8,000 over 10,000 or 0.8. So it's the change in consumption divided by the change in income. So here's some examples. What is MPC in these following examples? Number 1, you earn $100 and you spend 50. Well, if you spend 50 and you divide it by 100, that means your MPC is 0.5. Number 2, you earn $100, you spend 80. 80 over 100 is 0.8. And if you earn $100 and spend all of it, your marginal propensity to consume is 1. Now the flip side of that is the marginal propensity to save. It's how much people save rather than consume when there's a change in income. And again, it's expressed as a fraction or decimal. So MPS is equal to the change in savings over the change in income. So here's some more examples. You earn $100 and you spend 50. What is your MPS? Well, if you spend 50, that means you save 50. So MPS is 0.5. If you earned $100 and your MPC is 0.7, what's your MPS? Well, if your MPC is 0.7, that means you spent 70 out of your $100, which means you spent 30, or you saved 30, which means your MPS is equal to 0.3. So since disposable income is equal to consumption plus spending, the MPC plus the MPS has to equal 1. In other words, the additional spending from an additional dollar plus the additional saving from an additional dollar of income has to equal that additional dollar of income. Now, this idea of consuming and saving leads us to the multiplier effect. The multiplier effect shows how spending is magnified in the economy. There's a chain reaction that results in an increase in aggregate demand that is many times the amount initially spent. So it's best to illustrate this through an example. Super Bowl's coming up in a couple weeks, and people often travel to the city that hosts the Super Bowl and spend money. So the Super Bowl is often seen of as a boon to local businesses because it draws in tourists and money is spent locally in this area that would not have otherwise been spent there. So let's take a look at this idea of the multiplier effect. The idea is that first spending sets off a spending chain. So for example, Adam spends $100 on a room at Bob's hotel. Well, Bob's the hotelier. He's going to take some of that money, and let's say he spends that $100 that he got from Adam for a meal at Casey's restaurant. So he takes the money he earned as a hotel owner, and he takes the $100 and goes spends it at a restaurant. Meanwhile, Casey takes the $100 that he gets at that restaurant, and let's say he wants to go to dinner jazz club. So you see that initial $100 of spending resulted in $300 increase in total consumer spending. Each of these events increased GDP or AD by $100 times 3. But people save money. So how do we account for that in the multiplier effect? And this leads us to the spending multiplier. Let's assume that the government spends an additional $100 in office supplies. So normally speaking, government spending would increase by $100, which means AD increases by $100. Let's suppose the store owner that sold the government their supplies spends part of it and saves the rest. So let's ask, how much does she actually consume? Well, it depends what her MPC is. So let's suppose, for example, the MPC is equal to 0.8. That means she would save $20, but the remaining $80 she would spend again and put back into the economy. So the store owner spends $80, and let's suppose she spends that money on her groceries. Now that grocer has that $80 in income, he's going to spend some of it and he's going to save the rest. So if MPC is 0.8, he's going to end up spending $51.20 of that $80. That's 80%. Now this pattern is going to continue until there's no more income to pass along to the next round. So the question is, how much eventually gets spent? Now I'm going to show you math, and if you don't want to deal with the math, you don't have to worry about it. But if you are familiar with math, it might help you understand the concept a little better. So you will notice that this is similar to an infinite geometric series with a ratio of 0.8. Now, if you've taken math, you might remember the series. The sum of an infinite geometric series is the first term divided by 1 minus the ratio. So here the initial spending was $100. The ratio is 0.8, so it's 100 divided by 0.2, which is $500. Now you will notice $500 is 5 times the original amount of $100. This number 5 represents the spending multiplier. So the spending multiplier is equal to 1 over 1 minus the marginal propensity to consume, which is equal to 1 over the marginal propensity to save. As a result, there's a change in GDP that's equal to the initial change in spending multiplied by the spending multiplier. So in that Super Bowl example, let's suppose the spending multiplier was 3. Then the initial change in spending of $100 resulted in a total change in GDP of $300. So here's some examples. If MPC is 0.9, what's the multiplier? Well, it's 1 over 1 minus 0.9, or 1 over 0.1, which is equal to 10. If MPC is 0.75, what's the multiplier? This is 1 over a quarter, which is 4. If MPC is 0.5 and consumption is increased by $2 million, how much will GDP increase? Well, if MPC is 0.5, that means your MPS is 0.5, and that means your multiplier is 2. 2 times 2 million is equal to a total change in $4 million of GDP. So notice that initial spending of $2 million gets doubled due to the presence of the multiplier. Finally, number 4, if MPC is 0 and investment increases by $2 million, how much will GDP increase? Well, if MPC is 0, that means he's saving all of it, which means the multiplier is equal to 1. 1 times 2 million is equal to 2 million. So the spending multiplier multiplies the initial change in spending by the multiplier, and that total change in GDP is reflected in aggregate demand. So again, the spending multiplier is 1 over MPS. Some facts about it: the greater the marginal propensity to consume, the greater the spending multiplier. Now, on the AP test, you can't use calculators. So if you solve a problem like this, you're going to end up with MPC values that make fractions easy to work with, like 0.5 or 0.75 or so on. Remember, any change in spending that's a category of aggregate demand will be multiplied by the value of the multiplier. So that's spending. What about taxes? Now, if you remember, disposable income is equal to income minus taxes. So we saw that a change in income will change consumption or investment. Now we're going to look at the other half of the disposable income equation, which is taxes. So a change in taxes will also affect disposable income and thus aggregate demand. So the tax multiplier is different than the spending multiplier for two reasons. First of all, the tax multiplier is negative because an increase in taxes decreases disposable income and spending. So the change in taxes also must change disposable income before it changes spending. So this is different, where a change in CIG or XN immediately affects spending. But with taxes, it doesn't happen that way. So here's an example. A $1 change in taxes only changes spending by 1 times the MPC. So if MPC is 0.8 and taxes are reduced by $1, spending is actually only increased by 80 cents. And the reason is the households are going to save according to the MPS. So that means they're going to save 20% or 20 cents of the $1. So only 80 cents of those original dollar and extra money from a tax decrease goes back into the stream of commerce. So to calculate the formula for tax multiplier, it's negative MPC over 1 minus MPC equals negative MPC over MPS. And again, the change in GDP is equal to the tax multiplier times the initial change in axis. Keeping in mind, an increase in taxes will decrease GDP, a decrease in taxes will increase GDP. Now, what ends up happening mathematically is that the tax multiplier is a negative of 1 less than the spending multiplier, which means this. The tax multiplier is equal to 1 minus the spending multiplier. And that's the formula you'll probably want to know. So if MPC is 0.8, the spending multiplier is 5, 1 over 0.2. The tax multiplier is MPC over MPS, the negative of that, which is negative 4. Or, you will notice that's equal to 1 minus 5. If MPC is 0.9, the spending multiplier is 10. So the tax multiplier is negative 9, because negative 9 is 1 minus 10. So that's how the tax multiplier works. And that's it for section 3-2. If you have any questions, feel free to ask me in class or send me an email.